Hello students, in this video lecture I am going to explain a part of resolution of a force when a force is specified in between the 2 points. As we have studied already in the previous lecture that a force is defined as with a force as a vector defined as magnitude of a force into unit vector. But this unit vector when specified in between 2 points, so then how we can define the components of a vector along three direction, that is x, y and z direction. You can see now a force F I have expressed from point A towards B. It means that the point A is the origin, B is the end point. A is having coordinates x1, y1 and z1. B is having coordinate x2, y2 and z2. For this case, a vector is passing from origin A and ends with a point B. For this case, a vector F is expressed as magnitude of the force into unit vector from A towards B, and the unit vector is expressed as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap upon under root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. With this case, you can see that a unit vector from A to B is expressed. So, initial point A is defined as origin and the last point is defined as the end point. With this case, I hope you understand the concept of a vector when it is passing from one point to another point. By the definition, when we expressed is as magnitude of the force into unit vector from point 1 to point 2, or we can say that point origin to end point. So let's see one numerical based on this topic. The numerical is on the topic resolution of force when force is specified by 2 points and the vector is defined as magnitude of the force into unit vector from one point to another point. Question is, a transmission tower is held by 3 wires at B, C and D. If tension in AB is equals to 2000 Newton, tension in AD is equals to 1400 Newton and tension in AC is equals to 1600 Newton. Find components of forces acting at B, C and D. You can see the figure is given, and for this figure the axes are given X, Y and Z. The tower is held in this vertical position, and to keep this tower in vertical position, 3 wires are attached at point A. The wires are AD, AC and AB. The position of each point with respect to origin is defined, and I have noted down the position of each point with XYZ direction in this table. The coordinates of each point I have defined as from the origin. A point, for that I have defined the coordinates. As A is acting along the y-axis, it means that its x and z component or the x and z coordinates will be 0. So x and z coordinate are 0. So what is y direction? So parallel to this y direction, the distance is from the origin is 18 meter. So it is plus 18 above the origin. Then B is defined at this place. B is defined in positive z and negative x plane. Therefore, its y coordinate will be 0, and the coordinates are for the B, x coordinate parallel to the x line, it is it is 3.5 meter. Then as the axis is negative, therefore minus 3.5 meter. Then parallel to z axis, z coordinate is 5 meter. Then z is positive. Then coordinates of C, we can see C is lying in the positive x and positive z coordinate, in positive z and positive x plane. So C is having coordinates parallel to the x axis, distance is 12. So 12 is x, y 0, and parallel to z axis, the distance of C is 3.2. Then the coordinates of D, it is defined in negative z and negative x plane. So therefore y coordinate will be 0 and x coordinate will be parallel to this x axis. The distance is given as 3.5 meter, and with respect to z, parallel distance is defined as 12.5 meter, and it is negative z and negative x, therefore minus sign. As you define the coordinates, so let us start to define the force with each point. Now the coordinates of the point ABC when we define, so with that only we can start to find out the components of the forces. The forces are, the very first force I have taken as force TBA. As with respect to point B it is asked, so from B towards A we are representing the force. So what is a vector TBA? It is magnitude of TBA into unit vector passing from B towards A. So in this case, the magnitude of the force TBA is given as 2000, and unit vector is expressed as, it is from A minus B. It means that the coordinates of A minus coordinates of B, because origin is B, end point is A. So end point minus origin point coordinates. So then XA minus XB into I cap plus YA minus YB into J cap plus ZA minus ZB K cap upon under root of XA minus XB whole square plus YA minus YB whole square plus ZA minus ZB whole square. Now with this case, while substituting the coordinates from this table, we have to subtract A minus B. So coordinates of A minus B. While substituting the coordinates, I got the equation of TBA as a vector is equals to 368.293 I cap plus 1894.08 J cap minus 256.13 K cap. The x component of TBA is 368 because it is defined with the unit vector I cap. Y component of TBA is defined as 1894.08 Newton because it is defined with J cap. The Z component of the force TBA is defined as minus 526.13 Newton and it is defined as K cap. Now these are the components of this vector TBA. With the same manner, we can find out the components of TCA. So, vector TCA is expressed as with magnitude of TCA into unit vector from C to A. C is the origin point, A is the end point. With this case, we have expressed with TCA is given with the magnitude. TCA is given with the magnitude 1600 Newton. Now, we have expressed the equation 1600 in bracket, that is coordinates of A minus coordinates of C. Coordinates of A minus coordinates of C. With that case, we have expressed the equation and we got the components of TCA is equals to minus 877.96 I cap plus 1316.95 J cap minus 234. And with this case, we can say X component of TCA is minus 877.96 Newton because it is defined with I cap. 1316.95 it is defined with J cap, and 234.12 Newton is defined with J. It is K cap. It is minus. So these are the components of the force TCA along X, Y and Z direction. Component of the force TDA at point D, it is also asked. So the coordinates of A is 0, 18, 0 and the coordinates of B are minus 3.5, 0, minus 12.5. In this case, the vector TDA is expressed as magnitude of TDA into unit vector from D to A, because origin is D and end point is A. With this case, we can say the expression in that we can subtract the coordinates of A minus coordinates of A from D. So now vector TDA is equals to 1400. It is given in the question. TDA magnitude is 1400. So the coordinates of A minus D. With this, the expression we have vector TDA is equals to 220.79 I cap plus 1135.52 J cap plus 788.56 K cap. I, J and K defines X, Y and Z direction component of this TDA. So therefore X, Y, Z components are this. So with this case, we can express the component of a force when a force is specified from one point to another point. I hope you have cleared the resolution of a force in three-dimensional force system when a force is passing from one point to another point. Thank you.